Now that you've learned about formula questions with a single variable, you can do some more complex things. So we're going to add another question type, add another question. We're going to make this a formula question as well. And for this one, let's just say it's a molarity one. So what is the molarity of a, and we want to give them a volume of a solution. So let's say it's V, we're just putting that in there. You can put anything you want. What is the molarity of a whatever volume solution, so milliliters in this case, of a blah milliliter solution with, or that contains, however you want to phrase it. I'm just throwing this together on the fly, with, let's say, so many moles. I'm going to put M here, of solute. So we're looking to see if students can calculate molarity given the number of moles of solute and the volume of the solution. What is the molarity of a blah milliliter solution? Probably should put that one in there. With blah moles of solute dissolved. Okay, so of course students would need to convert milliliters into liters, and then you can use those two variables. So every student, remember that brackets gotta hold the variables. Every student will get a different volume and a different number of moles of solution of solute. So down here we see our two variables populate. Remember that anything that you put in those square brackets is going to be a variable you can use. And the ability to control the range is very important here. Of course, you do not want a zero volume solution because that's mathematically not going to be possible. But let's say we want a number between 400 and 900. So that's going to really test students' ability to convert to liters. And then we want the number of moles dissolved to be between, let's say, 1 and 3, something like that. We can also specify the decimal places. I'm not going to deal with the decimal places for the volume in milliliters because converting that to liters will already make it a decimal. But for the number of moles of solute, we can put 2 there. That gives us a kind of a 3 sig fig window. In the last video, we talked about how sig figs are not really a thing in Canvas. You can aim for 2 or 3-ish or 4 or something like that, but remember, it's not going to work out the way that we would like it to be. So in this case, we want students to calculate molarity, and let's see how I do that. You can put this here. This might be a little bit too much help, so maybe this makes sense. But you don't necessarily need to do that because a lot of the content in your course will already have students familiar with how they're expected to answer certain types of questions. So if you really do want to be explicit though, one of my favorite things to do is to give them a little answer box, which of course they can't actually interact with, and put the unit right after it. Alright, so in this case, we're going to want to calculate what's going on here. Now, we want our numerator to be the number of moles, which I decided to put M. Of course, I could put it in there. And then we're going to divide that by, now you have to actually take into account the fact that the volume that they're given is milliliters. So if they were given, for example, 543 milliliters, to convert that into liters, divide by 1,000. You want to put that into your coded formula as well. So the volume that they get, divide that by 1,000, and that gives them the correct denominator. So I am using parentheses. You got to use parentheses wisely. In this case, that's going to give us this molarity. Now, giving it some extra digits, we see it's 2.73. Always want to double check on pencil and paper and see to make sure that your code makes sense. So if we do 1.48 and divide it by 0.543, does it give us a molarity of 2.73? Now at this point, we can generate a certain number of solutions. So you have 50 people, 50 solutions, or 50 combinations. And let's say we're going to be a little bit stricter. We're going to say you got to be within 1%. Once we generate, then those are going to pop up, and you'll see what those potential answers are. And that means that all of your potential questions are going to be one of the 50 that you generate. So it's not going to make something that's unexpected. We're going to update. We're going to see what that looks like from the student perspective. So we're going to click Save, and then go to Preview, and we can see that we have what is the molarity of a 743 milliliter solution with 1.28. And actually, I made a mistake here. So this is actually really good. Always double check. Right here it just says 1.28. In my head, and this happens with some people, I was thinking, of course, it's moles, but it doesn't actually say that here. So we can easily fix that by keep editing this quiz, go to questions, go to edit the question, and we want it to actually say, of course, moles of solute dissolved. So easy fix. Doesn't actually change. Happy mistake, I guess, when I'm making this video. Doesn't actually change any of the stuff you have here. You can generate more. Let's say 50 is not enough. 60 is better. Generate some more. Those are going to populate. Doesn't change your formula. And we can update the question. But I guess I do want to show you this before I forget. You cannot copy and paste this formula. So if you do make a long, elaborate formula and you make a mistake, it might seem like all hope is lost and you got to start from scratch. But I've not seen anyone say this trick yet. And if you right click it, you get your little menu pop up. Then you can click Shift, hold Shift while you're pressing to the left, and that's how you can highlight it, copy, and then you could paste it and make some modifications if you want to. It does not let you actually interact with this directly as if it were normal text where you can copy it, so you kind of have to be a little bit creative. We're going to update question, we're going to save, we're going to preview, and now we see we get some different values here. So double checking with my calculator, if we have 1.91 moles and we divide that by 0.727 liters, we get 2.627 and some stuff. So within the tolerance range, let's say a student were to type in 2.63. So they did round it. Maybe even try 2.64. If they type in 2.64 and they click Submit Quiz, of course, we haven't answered the top one, that's fine. Scroll down, it is going to be right because 2.64 is within that tolerance range that we specified. So hopefully that helps out with learning how to use the formula questions feature in Canvas for both stoichiometry, which was a previous video, and in this case molarity as another example.